Use the rule for order of operations to simplify the expression as much as possible. This means that we are going to start with PEMDAS. I'm going to pick a nice color. Expand that out. So PEMDAS, P-E-M-D-A-S, stands for parentheses, exponents, multiplication, division, addition, subtraction. Now, multiplication and division are done at the same time from left to right, and addition and subtraction are done at the same time from left to right. Everything else, it's done left to right on its own, so they're in their own systems. So we're going to look at this first. We're going to say, do we have a pair of parentheses? Yes, we do. So in the pair of parentheses, we're going to repeat the PEMDAS, and we're going to look again. Do we have any more parentheses? This one we actually do. So we have a second set of parentheses that we're going to look inside first. At that point, we go, are there any more parentheses in there? No. Are there any exponents in there? There are no exponents in that little kit. Multiplication, division. We do have multiplication, division. We have 7 times A3. So we're going to do that, and 7 times 3 ends up being 21. So we have 21, and we have 8 minus currently in that little parenthesis box. Now that we've done our multiplication, there's no division, we're going to do addition, subtraction. We got one subtraction there where it's 8 minus 21. Anyone want to give me that one real quick? 8 minus 21? We're just going to go 8 minus 21 over here. I have to borrow that over. What? 13? Negative 13? Okay, so we're going to have negative 13 on the inside of that first parenthesis. And then there's a 2 on the outside of it. A minus. We're going to do the bracket on that side. 2 times 3. Close bracket. And then there's a 2 on the outside. We're just going to ignore this right now. So at this next step, we go back to our original parentheses and we say, okay, do we have any exponents? We do not. So then we're going to go multiplication, division from left to right. So that means that the 3 times the 2 will happen first. 3 times 2 makes 6. So it'll be 6 minus a 2 times negative 13. So at this point, we're going to, instead of doing this subtraction right here, we're going to actually multiply a negative 2 and a negative 13, and that will, there we go. That will give us a positive 26, because a negative times a negative is a positive, and 3 and 2 is 6, and 1 and 2 is 2. So we got 26 plus 6, which at that point will equal, now remember, this is still in the brackets, and on the outside we got a 2, but 6 and 26 will be 32. So we'll have 2, no, go away, bracket sign, 32, close bracket sign. And at this last point, we'll go, we don't have any more parentheses, it turns into multiplication, we'll go 2 times 32 is 64. And we have our final answer. Alright, now for question 2, we're going to do multiplication. With this one, we're going to use our grids to better help what we're writing. So we're going to go 72 times 81. Now at this point, I'm going to go first grid point of 1 times 2 is 1. It's 2, and then 1 times 7 is 7. So I got 72 in the first one. Now in the next one, because it's an 80, I'm going to automatically put a 0 down there as a space holder. If I went to a third line, I'd have 2 space holders for the next one and 3 space holders for the fourth line. That's just so that we move over the proper amount of zeros for the 10 spaces. So 8 times 2 will end up being 16, so we'll put a 6 down, and we'll put an imaginary 1 up here. When we do 8 times 7, we'll get 56, and then we'll add a 7 to that, so you will go to 57? Yeah. And then at this point, what we'll do is we'll add the 2 or 3, or however many pieces we get, and we'll bring them all together. So 2 plus 0 is 2, 7 plus 6 is 13. 13, so we're going to put a 3 down here, carry the 1, 7 and 1 is 8, and then the 5 stays by itself because there's nothing to go with it. So our answer at the end would be 5,832. And that's because we lined it up, and we first of all did our multiplication. And then we did our addition. I have really bad handwriting, but there we go. That's how we do that. Question 3, add using the rule of order of operations if necessary. So we're going to go back to our whole PEMDAS. P-E-M-D-A-S, PEMDAS, and we're going to look at our parentheses. So we have 1, 2, 3 different groups of parentheses. We're going to start with things that have multiple items in it first, and then we'll do the one on the end that's got a negative item. So we've got both our addition and subtraction, so we're not doing multiplication and division right now. So we have 2 plus a negative 3, which is just the same as saying 2 minus 3, which gives us a negative 1. We'll put him back in his parentheses for right now. We'll put a minus sign. We'll do the bracket. Now we got negative 11 plus 7, which means that we're taking 7 away from 11, which gives us a negative 4. And then we're going to put him back in his brackets, and we're going to add him to a negative 11. Alright, so we have negative 1 minus negative 4 plus 11. We're going to break them out of their shells now, and we've got to make sure that they keep the proper sign. So we have a minus 1, minus and minus means plus 4, plus a negative 11, so it'll be minus 11 there. That means we have a negative 1 and a negative 11, being negative 12 plus 4 equals negative 8. That's how we get our answer. We're going to say that those two happened there because I wanted to do the negatives first because it would be easier. Question 4 is now an evaluate question, which means we're doing the same thing before using PEMDAS. However, we get to do exponents this time. So we're going to write PEMDAS for minus again. And I'm going to start with parentheses. I see a first level of parentheses. I'll look again. Do I have a second level? I do have a second level of parentheses. So we're going to work on the inside of that parentheses first. There's no multiplication or division in there, but there is addition, subtraction. So we're going to add a negative 1 to a positive 3, which will be a positive 2. And then we'll remember that it's currently squared and multiplied by a 2. So at this point, we need to see what's our next biggest thing inside of this whole area between this and this. And brackets or parentheses. Nope, don't be eating my stuff now. All right, so there's a minus 4 plus 2. That's there, minus 5. All right, at this point, we got the second pair of parentheses, and we're going to look around that to see if there's anything special. There's multiplication, and there's an exponent. We need to do our exponents first. So it'll be positive 2 times positive 2, because that's what's inside the box. Positive 2 times positive 2 will be, I'm going to move over here because of the sunlight, 4. So this became that. We're going to keep it inside of its parenthesis for right now, minus 5. Keep that in there. This is still multiplied by a 2. We haven't done that part yet. We're going to add a 4. It's negative. Keep that. So we brought everything else down. We just squared that 2 into a 4. We're now going to multiply 2 to 4 because it's the only multiplication that we have in there. So 2 times 4 will be 8. And then we'll bring everything else down again one more time. Plus that negative 4. And then on the outside is a negative sign. There we go. And now we're going to do addition and subtraction inside the parentheses. So we have negative 4 and a negative 5, so that'll be a negative 9. And we have a positive 8. Sometimes it's better to... Lost half of our math. We're going to go back and do this one more time again. So we're going to do the 2 times the 4, and that's going to give us the 8. We have the minus 5 on this side of it, and we have the positive 8, but it's a negative 4 in front of it, and there's a negative sign in front of the whole thing. At this point, we are going to take the negative 4 and negative 5 and put them together to be a negative 9, and we have a positive 8. And all of that is inside of the last brackets with a negative sign on the outside. Positive 8 and negative 9 will make a negative 1 on the inside of those brackets. However, we have a negative imaginary 1 on the outside of that, so we're going to multiply them together, and it's going to give us a positive 1. That, folks. We're going to try this one more time. So this became a negative 1. We're going to put that in the parentheses, have a negative on the outside, and that equals 1, and it is positive. We're now going to question 5. Subtract and state your answers in reduced terms. So, because we're having to do addition, subtraction of fractions, we need to find the greatest common factor between the two of them. Or least common multiple. Least common multiple, not greatest common factor, least common multiple. We could do this by isolating out their terms and seeing what they multiply to. For example, the factor tree of 12 would be 3 times a 4, which would be a 2 times a 2. And then we would go for 21, factor tree it to 3 and 7, which are both prime numbers. And we realize they both have a 3 commonly. So if we eliminate one of those 3's, then what? 3 times 2 times 2 times 7, we would get the greatest common, or the least common multiple between them. Okay. So 3 times 2 would be 6, times 2 again would be 12, and then times 7, we get to do some fun long division over here. So 12 times 7, or not long division, but long multiplication. 7 and 2 is 4, carry the 1. 7 times 1 is 7, plus 1 more is 8, so 84. So 84 will be the common denominator between the two numbers. At this point, we'll be wondering, what do we need to multiply the top sides by? Well, the fun fact is you just take whatever is on the opposing primes and multiply them over. For example, for 5 here, we're going to have to multiply it by both of these 2's, because in the 21, we don't have a set of 2's. They don't exist there. So we'll just multiply him by 4. Because we'd have to multiply 21 by 4 to get to 84. So we'll do 4 times 5, and that will give us a 20. And for the 12, we look over and say, well, we've got a 3 already in there, so that's not going to help us. But if we go 7 times 12, we'll get 84. And we know that because we just did the math on it to get there. So that means it'll be 2 times 7, which will give us 14. At this point, we'll notice that our thing is going to become negative. 14 minus 20 will give us a negative 6. And then we will have 84 on the bottom. And now we need to reduce it and simplify it. We know that we can simplify it because both of those are divisible by 2. So we're going to divide both of those by 2, and that's going to give us a negative 3 over, divide this by 2. 8 goes into, or 2 goes into 8 4 times, and then into 4, so 42. So you have 42 as a number, and then just because we know our multiplication tables really well, we're going to remember that 42 equals 30 plus 12, which means that it's actually divisible by 3. So we're going to divide it again one more time, which it would be a 10 and a 4. So that means that the bottom side will be 14, and the top side will be negative 1. So we're going to start here with question 6. So they want us to simplify 2 different sets of fractions over each other. So we're going to work with one half, and then we're going to work with the other half. I'm going to start first with the 3 over 4 plus 1 over 3. And I need to find a like denominator between the two. 3 and 4's common denominator is going to be 12, which means that we need to multiply both the bottom and the top of this side by 4, and we'll have to multiply the bottom and the top of this side by 3. So when we do that, we will get a 12 base plus 12 base, and then 3 times 3 will be 9, and 1 times 4 will be 4. And we will then do that over, and now we'll do the other half. Look out, we're going to change our colors real quick. We're going to do 4 over 5 minus 1 over 2. Now, does this color stand out better than that color? Do you like the red better? Okay, we're going to keep working on the red then. But when we go to this, we'll go 5 and 2. The least common denominator between 5 and 2 will be 10. So we will then do our multiplication of 5 over 5. And over here, we will do 2 over 2. And the reason why we... Oh, give me back my 4. The reason why we do the same number over the same number is if you simplify this equation down, it would literally be 1 over 1. And that's the same as any number over itself, so you're giving an identity problem. This is subtraction. It disappeared. So that's why we do these numbers same over the same. So then we'll do 2 times 5, which will be 10. And then we'll do 2 times 4, which will be 8, minus 1 times 5, which is 5, over 10. And that will equal... I could start doing all these numbers, but here's the fun part. We're going to take this whole section here and put it underneath. 8 minus 5 over 10 each. Now at this point it looks really scary and we have a lot of big numbers going on. However, we have common numbers in each of our denominator sets above and below. So what we're going to do is we're going to take this entire top part and we're going to multiply it by 12. We're going to take this entire bottom part and we're going to multiply it by 10. When we do that, we cancel out all of our denominators. Which means that they end up being 1. So anything over 1 is itself. Which means our next equation will be written as 9 plus 4 over 8 minus 5. That looks a lot easier all of a sudden. We're going to take those numbers and we're then going to add and subtract. 9 plus 4 is going to be 13. We're going to have 13 over 8 minus 5, which will be 3. And that is not a divisible number set, so 13 over 3 will be our fraction in the end. I'll put a star there just so we know that's the one. And we're going to do multiplication again like we did earlier. However, we have to remember that we have to go 1, 2 spots out, 1, 2 spots out. So we'll do this real quick. We're going to do 9, 1, 6. So it'll be 916 is what we're going to call it as right now. And we'll have it multiplied by 212, which is 212. This means we're going to get 3 separate lines of math. So let's do this real quick. 2 times 6 is going to be 12. Put the 2 down, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 9 is going to be 18. No carryover, so we'll have 18 there. So the first line is going to get 1, 0. And then we're just going to repeat the number because it's multiplied by 1. And then we're going to go to the third line, which is going to get 2 zeros added to it. And then we're going to do the same number that we did earlier, only with the 2 zeros. So 2 carries over, makes a 3, and gets an 18 in front. And that's how we're going to do that number. Let's bring down and add all 3 of these lines together. So 2 plus 0 and 0 is 2. 3 and 6 is going to be 9. 8 and 1, or 8 and 2 is going to be 10. Then we're going to put another 1 down there for 11. Carry the 1 up here. 9 and 1 is going to be 10. 3, 4, so that's going to be 14. Carry the 1. 1 and 8 is 9, and 1 there. Now remember, we moved 2 spaces on the first one, and we moved 2 spaces on the second one. So we're now going to, because it came back, move 1, 2, 3, 4 spaces over. At that point, we'll say that the answer will be 19.4192. Remember, if you're moving 2 to the left, you're going to move 2 back to the right when you're done with your equation. Right, we're going to do division, but again, we do not like decimals, so we're going to move them out. 1, 2, 3, and 1, 2. So that means we'll have 317 is dividing into 1, 3, 3, 1, 4. Ooh. This is not going to be pretty. So first of all, we know that it's not going to go into 1, it's not going to go into 13, it's not going to go into 133 because it's 300 and something. At that point, we know it'll go into 1,300, but we don't know how many times. So we're going to multiply this by roughly 4 because I know that 3 goes into 12 4 times, so I'm going to guesstimate that. If it's too high, I'll just immediately use 3. So let's do this over here as a quick math of 4. So 4 times 7 is going to be 48. Put the 8 down, carry the 2. Not 48, 28. 4 times 1 is going to be 4, plus 2 more is going to be 6. And then we're going to do 4 times 3, which is 12, which actually fits because it's 12, 68. But we're not going to be able to fit another 300 in there, so we're going to use that number. I'll put the 4 up here, and then we're going to where do we want to? 1, 2, 6, 8. Carry this down, do the subtraction. We're going to have to borrow 1 from here, making this a 2 to make that an 11. 11 minus 8 is going to be 3. We're going to put the 3 down there. Since it's a 2, we're going to have to borrow 1 over here, and that's going to be 12. 12 minus 6 is going to be 6. 2 minus 2 is going to be 0, and that's going to be 0 as well. And then we're going to bring down a 4 because we can do that now. Now I'm going to say that 7 and 7, I know for a fact that's going to be 2 times because the number looks good and it's close. So we're going to say if I did 7 times 2, it would give me a 4, carry the 1. We would then do 2 times 1, which would be 2, carried in a 1, which is 3, and then we're going to go 2 times 3, which would be 6, and that's how you know that this equals 317 times 2. All right? So that means we're going to put the 2 up here, and then we get to write down 6, 3, 4, and we know that they're all going to cancel out there. All right? So we've canceled that, and that's where we have to look up at our division. And we're going to have to move it over 3 times, and then back 2. So it'll be 1, 2, 3, and then we got to go back 2. So that means.
Why do you go back 2?
Now the reason why we go back 2 is because since we're doing division, this needs to go the reverse direction, and this needs to go the same direction. It's a really odd concept, but only when you're doing division, the one you're dividing by counts against your decimal move. So starting at 0.00042 as our answer, we had to move 1, 2, 3 back into the positive, and then we had to use 1, 2 into the negative, and that gives us 4.2, which if you think about it, roughly guesstimating 4.2 and 3.14 would give you something a little bit over 12 because 4 and 3 is 12, and we look up at our number's 13, so by guesstimation rules, that checks out. So we're going to actually use 4.2 as our number. Question now, we're going to do simplifying, and in this one, we have to do distribution of numbers. And the way we're going to do that is we're just going to grab the number in front, and we're going to multiply it by both items inside, and then we're going to cancel out like items. So we'll do, for example, the 3 is going to multiply by the 5w to make 15w, and the 3 will multiply by the -2, which will be -6. Now the fun part for the second one is we're going to include that sign with the number in front of them. So when we do that, we're just going to say it's a plus sign in there, but the -7 is going to multiply by every number inside of there, and it's going to flip signs. That's how we treat that symbol. Yep, so the first part will be negative 7 times 3, which will make a negative 21. And then negative 7 times negative 4w. Negative times negative will be positive, and it'll be plus 28w. At this point, I'm going to put like items next to each other. So we're going to take the positive 28, and we're going to move it over with the 15. So we'll have 15w plus 28w, and then we'll do minus 6 and minus 21. And this is all because we're saying every sign that stays in front gets stuck to that now as its personal sign. So we boxed them all up, we moved them around so they're now better rearranged. We're going to go 15 plus 28, 5 and 8 is going to be a 3, so we put down a 3, carry a 1, and that'll be 2 plus 1, carry the 1, will be 4, so it'll be 43w plus, and then actually we're going to have to make that a minus sign because we're going to have minus 6 minus 21, which is going to make minus 27, so it'll be plus a negative 27, which then ends up being 43w minus 27 as our simplified form. Because it's not equal to 0 or equal to any number, I cannot turn w into equaling something because I don't have another side of an equation. But I've broken it down to w's and regular numbers. So that'll be our answer. Reading again, however, this is a fraction. People don't like fractions. We're not going to use the word fraction. 3 divided by 7 times 14x minus 35 is a big number set and it looks terrifying. However, another way of writing this is that we have 14x minus 35, which is inside the box, is multiplied by 3 and then divided by 7. So we're going to distribute the 3 to both, and then we'll distribute the 7 to both. I'll show you how this works out in a moment. So 3 times 14 is going to be 14, 3, 4 and 3 is going to be 12, carry the 1, 3 and 1 is going to be 3, plus 1, 4, so 42. So we'll have 42x minus, and then we're going to do 35 times 3. 5 times 3 is 35, 3, and then we're going to do 3 and 5 is going to be 15. Put the 5 down, carry the 1. 3 times 3 is 9, plus 1, 105. So we'll have 105 as our number. But remember, on the outside of this, we still have that divide by 7. So now we're going to divide each number by 7 individually. I need to move this up. There we go. So now we're going to do 42 divided by 7, which is going to be 6x, and then 105 divided by 7, I'm not sure, so let's check here. 105, can this go into 10? Yes, it can go into 10 one time. Put the 7 down, put the 3 there, carry the 5 down. 35 can, 7 go into 35? Yes, it can. It can go in 5 times, gives us 35, cancels out, so that means 15 times, so that means minus 15. And that would be how we simplify this answer here. Okay, so now number 11 is going to be solved for w given that p equals 3l plus 5w. This is close to a perimeter equation, but it's not quite. What we're going to be doing is what's called reverse PEMDAS. So PEMDAS is when you have the equation equal to a set number and you only have one variable, so it's easy to pull it out and make the variable equal to something. But in this scenario, we can't do that. So what we need to do is we need to reverse items away from the w that we want to be equal to everything else. And we're going to do that by putting PEMDAS in reverse, which means we're going to add and subtract first, and we're going to multiply and divide, and then after that we'll do exponents and parentheses. We have those, but we don't even have those this time around, so these guys, we're going to ignore them. So we'll start out with subtraction and addition. If I'm looking at 5w, 5 is bonded to the w with multiplication division. I can't do that yet, but the 3l is only bonded with addition subtraction, which means that it's easier to break that link. So we're going to break that link by subtracting 3l from both sides of the equation. And when we do that, it'll be P minus 3L equals, the negative 3L cancels with positive 3L, and we'll say 5W. At this point, we have nothing else that we can add or subtract away from the W, so we'll move up to our next one, which is multiplying and dividing. Since we have a 5 here multiplied by W, we'll want to divide it by 5 to cancel it out, and we'll have to do it on the other side to keep both sides balanced. And then we'll be able to cancel out both of these 5s, and that leaves us with W equals P minus 3L over 5 as our answer because we have solved it for W. For number 12, we're going to do a solve for x given, which means I need to distribute out the numbers first, and then we're going to use reverse PEMDAS to bring the x to one side of the equation and all the rest of the numbers to the other side. Start with our division, or our distribution, because that'll give us our true numbers. So we'll do 2 times x, which will be 2x, 2 times a negative 5, which would be minus 10, plus 3 equals, and then we're going to do it again, negative 9 times positive 2 will make it negative 18, and then we're going to do negative 9 times x, that'll be negative 9x minus 3, and this will be our 3 different number sets. Now we're going to start simplifying by condensing numbers that are on the same side. For example, we have a minus 10 plus 3. We're going to add those together, and it'll be a negative 7. I have a 2x there, equals, and on this side, I have a negative 18, I have a negative 3. Those are the same item, because we can't merge x with regular numbers. We're going to put the two of them together, and it's going to give us a minus 21 minus 9x. Now, at this point, we want to move all of x's onto one side and all of the other number onto the other side. I would personally move the 9x because it's negative and greater, so when we move it over, it'll make a positive number because we want to have a positive x at the end, or we'll end up having to divide everything by a negative, and that's not going to be fun. So we're going to add 9x to both sides. When we add 9x to both sides, we're keeping the equation balanced, and we're saying this negative 9x and that positive 9x no longer exist. So that gives us a total of 11x minus 7 equals negative 21. Now again, at this point we're going back with reverse PEMDAS, and we still have some addition subtraction to do. We're going to try and cancel out the 7 here, so we're going to add 7 to both sides. When I add 7 to both sides, these 7s cancel out, and I'm stuck with 11x equals, we're going to add 7 to a negative 21, which will take away 6, so it'll be negative 14. Check? Anybody? Anyone check me on that? Negative 14? Cool. Alright, so at this point, we have only division left, multiplication division. We want to get rid of that 11, so in order to get rid of something that's multiplied 11 times, we're just going to divide it by 11, and the other side will be stuck with that. That will give us x equals negative 14 over 11, and that will be our answer. Question 13, we're going to start this out by putting all the p's on one side of the equation line, and then we're going to do division. So we're going to move all the p's over to the positive direction, and because both these are positive numbers, I'm going to subtract one of them away. I'm going to subtract away the smaller one, so we're going to subtract away the 2.1p from both sides. So when we do this, it's going to cancel out this one side, and we're going to have 3.7 minus 2.1, so we're going to cancel out 2, so it's going to be 1.6 as a positive p-value equals 4.48. At this point, we're going to have to do a division of 1.6 on both sides. 1.6 divided by 1.6 cancels out, and we'll have p equals 4.48 over 1.6. Now going back to our earlier thing, we're going to move our decimal places out, and then we're going to do long division. So we've got 16 and we've got 448. And we know that 16 will not go into 4. However, it will go into 44. I'm going to say it's going to go into 44 3 times, because 1 times 4 would be 40, and then 1 times 6 would be too much. So we're going to start it with a 3. 3 times 6 is going to be a 18, so we're going to put an 8 down, carry the 1. 3 times 1 is 3, plus 1 is 4, so 48, so that still won't work. So we know that 3 won't work either, so we'll do 16 times 2. 16 times 2 will give us 6, and 2 is going to multiply to 2, carry the 1. 2 and 1 is going to be 2, plus 1 is going to be 3, so 32. That seems like a good number, so we're going to put a 2 up here, and we're going to put a 32 down below this. 44 minus 32 is going to end up being 4, so 2, carry the 1, 12, 128. 128, 16 will go into that 4 times, I think. 5, 6. We're going to have to just try it over here. We're going to do 16 times, I'm going to guesstimate it at 8 and see how that works. Today's 48, so we're going to put an 8 down, carry up a 4. 8 times 1 is going to be 8, plus 4 more is going to be 12, so 128 will be perfectly 8 times 16. 128. Going to cancel out to a 0, so we know that this 0.028 will be the answer, and we have to move 1, 2 back in because of the 2 that we moved out on the top part, and the division will move us back in another direction, so we'll have 2.8 will be our answer, equals P. In 14, solve for x given. We have fractions. We don't like fractions, but hey, they're all by 3. So what I'm going to do is I'm going to say everybody here, both sides of the equation need to be multiplied by 3. When we do that, we're going to do 2/3 times 3. It's going to give us 2x plus 4 equals -3. And we did that to cancel out both 3 values, and then we ended up multiplying a -1 by a -3. At that point, we're then going to move 4 over because we're doing reverse PEMDAS again. So we're going to subtract 4 from both sides, and that's going to give us a 2x equals -7. And at that point, we need to just divide over the 2 to get it away from x, and we'll end up with x equals -7 over 2 as our answer, and that's solved for x. So, question 15, solve the inequality. So when it comes to inequalities, we know that this sign will roughly stay the same unless there's a negative division. We're going to attempt to not deal with negative divisions, but if one does happen, I'm going to just take this line here, and I'm going to run a line across it to tell me that I flipped signs. All right? We're going to keep it as simple as that. But for right now, we're just doing addition, subtraction, and I want to move all my x's to the positive form. Because I have 1 negative and 1 positive, I'm going to move the negative over towards the positive, which means I'm going to add 4x to both sides. And that's going to cancel these 2 out, and we're going to have plus 5 is less than or equal to, and we're now going to put these together, a -8 plus 4 and a 7 is going to be 11, so 11x. At this point, I want to get the numbers away from the x's, so I'm going to now add 8 to both sides. 8 and 5 is going to be 13. So 13 will still be less than or equal to a positive 11x. Because I moved the proper direction, I don't have a negative number to divide by, so I will not be flipping this sign. However, I got to divide both sides by 11, and that means that 13 over 11 is less than or equal to x, or if we want to write it around the other way so that the teacher likes it, it'll be x is greater than or equal to 13 over 11. And that will be our answer. This line chart beforehand so we could see this better. But the first thing we need to do is start with our math. So we're going to have the negative 2x minus 3 is greater than or equal to negative 15. We need to move everything over to the other side, so we get x is equals or less than or greater than some number. So we're going to do that first of all by adding 3 to each side of the equation mark, and that will then give us a negative 2x. I'm losing my numbers. 2x is greater than or equal to a negative 12. And we did that because we said, well, we add the 3 in, but since it's a negative number, we can say there's 15 bad guys in an alleyway. We put 3 good guys in there. They all shoot each other up. That means that all 3 good guys are gone, and they were able to shoot up 3 of the bad guys. On this side over here? It's still, we're subtracting it. Wait, yeah, I'm canceling it out. I put a plus there. It's just, as this thing goes later on, it's going to start trying to pull the numbers I write. So if you see stuff get blanked as I'm writing it, just let me know. Because it also appears that way on there. Did it just move something? Okay, no, it didn't. Okay, good. So at this point, I've got a negative 2x and I've got a negative 12. This is where they forced me to have to do a negative x division. So we're going to divide both sides by negative 2. This is where we have to remember to flip our signs, because they made us do it. Negative 2 over negative 2 cancels, leaving us with an x on that side, and negative 12 divided by negative 2. Negative divided by a negative will be a positive, and 2 and 12 will give it to be 6. That means that x will be less than or equal to positive 6. So, you don't have to put the plus sign. I put it there just to remind myself it is positive, because we're dealing with both positive and negative numbers. At this point, I'll go 1, 2, 3, 4, 5, 6. That's our 6th line right here. And on a line, this is an equal, so the dot will be filled in, and then the line will go all the way, all the way to negative infinity, because x is less than it. Another way you might see this is they would use a bracket at that point, and then they would draw the line from the inside of the bracket all the way over. And this is just regular stuff, but if they said, if they said they wanted it in interval notation, we would remember that it's going from negative infinity, and it's going to 6, and it's going to actually touch 6. And that would be how we'd write the interval notation for this. I just want to see if any of my students here know what the robots and owls are. Does anybody know robots and owls? Okay, so we're going to have a fun little thing. This is a way to make sure you always get your signs right when dealing with greater than, less than, equal tos. We've got these big circles, you know, when you use those on a line chart, and they go off to infinity and they're open. Those are when you use the greater than sign and the less than sign, right? And when you use those, you use parentheses with them. That is my owl. I'm trying here to draw. This is not good with arting right now. But that's my little owl. And owls are soft and fluffy, so you could, you know, try and touch him, but he's just going to move out of the way. And that's why infinity goes with owls. And any number that you're trying to touch and you don't quite touch it turns into an owl. On the other hand, the other ones are those, you know, little filled-in beady dots on the graph. And they have the greater than or equal to and the less than or equal to sign. And those go with brackets, right? So this is my robot. He's got tanked treads, and he's got this weird extra mechanical bits, and he's got those little laser dot LED eyes. So this is my robot right here. And my robot, he listens to instructions very well, and he runs right up to a point, and he stops there. So every time you're actually going to touch a point, you use a robot. And all you got to do is cover over 1/2 of your robot drawing, and you realize that a small dot is a greater than or less than sign with equal tos and is a bracket. If you cover 1/2 of your owl over, you suddenly realize that your owl has big open dots equals greater than, less than sign, equals parentheses. And now you'll always remember your owls and your robots are two different things, and you can look immediately at a sign and go, I know which one that is, because it's either an owl or a robot. Everyone online, you can see the drawing there. Good luck trying to remember it. It's a good story. But that's how to help look at interval notation. In question 17, we're going to start with some word questions, and in this point we're looking at area. And we know area equals length times width. And we already have the area of the full driveway, and then we know that a paver is going to be 11 by 13. So in order to figure out the full total area of the paver, I'll have to multiply those together. And then we're going to take the total area of the driveway and divide it by what each individual paver is personally liable for. So we'll do 11 and 13. And we're going to multiply them together. 1 and 3 is 3, 3. Put a 0 down on this side. 1 and 1 is 1, so it'll be 10, 11. So we'll do 3, 4, 1. So we know that one brick alone will be 143 square inches. And we have a total driveway of 17, 58, 9. So at this point, we're going to see how many of those 143 area cubes fit into that bigger area. Go with that, and we'll say at one time there, so 143. And then we'll do 3 from 5 is 2. 7 and 4 gives us 3. This cancels out, and we'll move down our next number line, which is 8. At this point, I'm going to guess that this number will multiply into it 3 times, because it looks like it'll fit 3 times. I see that it's 3 fits into there, and then, oh, it's not going to fit in 3 times. It's going to fit in 2 times. So we'll do it 2, and then we'll do 3 and 2 is going to be 6. 2 and 4 is going to be 8, and then 2, and that's going to be 2. So that'll be 286. We're going to do our subtraction across. They're going to give us a 2 there. We're going to have to borrow 1 from that to give 12. Who had my numbers there for that? They just went away. Who has those numbers? Everybody? 2.8. Is it? Yeah. Is it 2? Yeah. 286 because it was multiplied by 2. Because it just pulled those away. Okay. So going back to this over here, we carry over a 1. So 12 minus 8 is 4. And then since that's canceled out there, it's a 0, 4, 2, and then we'll bring down a 9 by 3. 3. It is. That's the number, isn't it? Okay. Okay, cool. So we'll do 143 by 3 just to test it. 3 and 3 is 9. 3 and 4 is going to be 2. Carry the 1. 3 and 3 is going to be, 3 and 1 is going to be 3. Plus carry 1, 4. 428. So we'll just 9, 429. They both cancel out. And this was multiplied by 3, so it'll be a 1, 2, 3. So it'll be 123 blocks in our full area. So at this point, we have the rectangular room as 4 times as long as it is wide. So what they're trying to tell us is that L equals 4W. And that's one equation. The other equation that we know is that the perimeter equals 2 length plus 2 width. This is going to be a very key formula in figuring out length and width and boxes. Lots of boxes. We also know the perimeter is 48. But we're going to hold off on that information for right now. For right now, what I want to do is, if I want to set an item equal to one variable, I could do that. However, I have 3 variables here. I could get rid of one of the variables by saying 48 equals 2L plus 2W, but again, I can't pull one of those variables out. What I want to do is substitute. And they gave us the ability to do that up here when they said L is 4 times W. So in that case, wherever L is, I could just put a 4W instead. So we'll go 2 times 4w plus 2w equals 48. Now at this point, we only have one type of variable, which means we'll be able to solve this down and figure out what the width of the room is. So we'll do 2 times 4. That'll give us 8w plus 2w equals 48. At this point, we'll then add these together to be 10w. And someone did their math bad. We're going to end up with a fractionary statement here, where we'll divide both sides by 10, and we'll get 4.8 equals w, because we canceled, brought down to 0, and we basically just moved the decimal of everybody over 1. Okay. So I've got my width being 4.8 feet. Question done, right? Solved? We good? Happy? Anybody who did that just got wrong. Because we were asking for the length of the room. So they trick questioned you. They gave you an answer, but they didn't give you the answer you need, so you now got to go plug that back in. Because we know that the length is 4 times the width, we're just going to plug in 4.8 times 4 equals length, and then we'll just do the multiplication over. 4 and 8 is going to be 32. Let's put a 2, carry the 3. 4 times 4 is 16 plus 3 makes it 19.2. So L equals 19.2. I really hope this is the right one. I think somebody just flipped some numbers but didn't fully think of where the equation was going, so it ended up with decimals this time around. But these numbers shouldn't end up with decimals in your regular class and on your test. The 4.8 came from 40 equaling 10w, and then we divided both sides by 10. So that left us with 1w will equal 4.8. And I kept it in decimal form because it would be easier just with the simple multiplication we had to keep it in decimal form rather than put it in fractions. Because fractions doesn't give you a really good measurement type. Because when you're dealing with tape measures and room measurements, it's better to keep with decimal numbers. In question 19, we're going to do basically the same thing. We're reading the length of a rectangular garden is 6 feet longer than it is wide, which means that in this case, L equals W plus 6. And if you have a hard time remembering this, the length will always be longer than the width just because of terminology. So always L will equal the W done with it. So that's where that's going to come into play. As for it, we know that the perimeter is going to be 192 feet. Is P, not R. Come on. We're just going to ignore that ever happened. P equals 2L plus 2W, and we're going to write that down here as equals 2. I'm going to put a blank here because that would have been L plus 2W, but now we're going to insert this piece into there, which is W plus 6. At this point, we have to do distribution. So we'll do 2W plus 2 times 6 is 12 plus 2W again equals 192. At this point, we will now move the W's together, and then we'll move the numbers across. So 2W and 2W, because they're like terms, will be 4W plus 12 equals 192. Gotta move my screen down. We're now going to do reverse PEMDAS to get everything away from W, right? Because we now have the equation all set up. We're going to do, oh no, don't do that. We're going to now subtract 12 from both sides of the equation. It's going to cancel out on that side. We're going to get 4W equals, we're going to take 2 out, and we're going to take 1 out, so that'll be 180. Yes, no, yes, yes, okay. We're going to divide this by 4 on both sides. And it does look kind of scary that we're dividing 180, but we're actually just dividing 18 with a 0 on the end of it. So 4 divided by 18. So actually, we may not be able to do that one. It's not going to be a flat number. Okay, so if we did 160 and then we added 20 more onto it, that would be adding 5 more. So 160 into 4 is 40, right? So we'll know that we have 40 because 4 from 160, and then we've got 20 left over, right? Divided by 4, which is going to be 5. So we're going to add 40 and 5. We're going to get 45 equals W. Cool? So what we did is we just put the 4 in the 160 and then the 20 with the 5, and that's how we break things up to do good guesstimations. From there, we done? 45 equals W, right? Right? Everybody? Yes, no? No? Okay. The people here actually sitting here realized that we're looking to find the length of the garden this time around. Can't trick them twice. So we're now going to write that L equals W plus 6. We know that W is 45, so we'll insert that. 45 plus 6 equals L. Do the numbers there. We'll get 51. Jeez, I'm really messing up here. Equals L. And we know the length of our garden and the width. Question 20. Frederick needs to borrow $10,000 on a down payment for his new car. Okay, that's about right. His uncle decided to loan him the money at a 5% loan. I like his uncle. That's a pretty good loan rate. So that's going to be, does not want to pay more than $1,500 in interest. How many years does Frederick have to pay back the loan? This goes on the principle of I equals PRT. Interest equals the principal times the rate times the amount of time intervals it goes by. At this point, we'll start looking up at our parts and say, what can we plug in? So I know that the principal is $10,000 because he pays $10,000. I know that it's a 5% rate, but I got to turn 5% into a decimal, so it'll be 0.05. So we'll put 0.05. Time, we're not sure what time is right now, so we're going to ignore that part. And then we know that he wants it to be less than $1,500. I have 3 numbers. I have 1 variable. We're going to condense some numbers together. So if we're going to multiply 0.05 times 10,000, we're just going to move that over to make it a 5 right now. We're going to go 10,000 and then 5. You get 0, 0, 0, 0, and then that's going to be 5. So you get 50,000, but you got to move it back 2. So you go 1, 2, and you find out that that's 500. Cool. So 500T equals 1500 in dollar amounts. So at this point, we're now going to say we want to get T alone. So we're going to divide both sides by 500. Right? 1,500 divided by 500. All I'm going to do is, since I cancel these numbers out, and I've got this fraction here, I'm actually just going to ignore. I'm going to destroy both the zeros, and I get 15 over 5, which will be 3 over 1 equals T, which means that the amount of years that he has to pay back the loan is equal to 3 years. That is how long he has to pay back that loan before he would be paying more than $1,500 interest. Where is... Hello? Alright, question 21. At a restaurant, your bill becomes $80. So we know that it's going to be $80. And we need to leave a 16% tip, which would be 0.16 in decimal form. How much do you need to leave for the tip? Just the tip, not for the whole payment. So what we're going to do is we're going to say $80 times 0.16. And we're going to move down our decimal place 2 over, and we'll do 80 times 16. 6 times 0 is 0. 6 times 8 is going to be 48. 1 times 0 space holder. 1 times 0. Yep. Hundreds, so we're going to carry this down. It's going to be 0 there. 8, 4, and 6 is going to be 12. 1,280, but you're going to want to remember we moved 2 decimals out, and since multiplication, they just reverse, so 2 decimals in. So that means our tip will be $12.80. Now, if they said total, they wanted the total number, you just add that with 80, even though this was our answer for this one. I really want to, what? Right. $92.80 in total. But that's just for the in total. You got to remember, read the question. It's very important to know what the question asks. Tracy paid $120 for an item that was originally priced at $400. What is the percent of the original price did Tracy pay? There's an equation for this, simply called new minus old over old. It's also known as last minus first over first, but new minus old over old sounds a little bit better rolling off the tongue. So we know that the new value is 120 and the old value was 400. So if we did that, we'd go 120 minus 400 equals 400. We'll now do the math of this. 120 minus 400 will give me, I want to say, 280. Negative 280. Negative 280 over 400. And because we're looking at the percent of change, it doesn't matter that this is negative right now. We can actually make it positive. So we're just going to say, because change is a distance, no matter what, it's always going to be positive. You can't have a negative distance between 2 points. So even though this ends up being negative, we'll just say that it keeps being positive. And that's always for all of these. At this point, we'll start doing the division of it. We can take away the zeros, putting it at 28 over 40. We can divide both of these by 2. If we did that, we would get 14 over 20. And then you would say you still divide it again by 2. So then you'd get 7 over 10. 7 over 10 would be a percent, which would be 70%, I believe. 70%? Yeah. So that'd be 0.7, which would also equal 70%. So that means that the price that she paid is 70% off. So that would be 100%, my bad, minus the 70% equals 30% left over. So that means that the percent of the original price that she paid was 30%. Finding the x-intercept of the lines of ordered pair, all we're saying is when we say variable, whichever variable, intercept, that just means that the other variable, so for example, if it's x, we're going to say y, automatically equals 0. The other variable just equals 0. If we're looking for the y-intercept, then the x variable will equal 0. And then we plug it in up here. So we have negative 3x plus 5y equals 21. We said that we're going to plug in 0 for y, correct? Which means 0 times 5 is 0. So this is just a big fat 0. It doesn't exist anymore. So we'll have negative 3x equals 21. At this point, we're doing our reverse PEMDAS again. We have no addition or subtraction to take care of. So we're just going to divide both things by a negative 3. When we do that, we cancel out negative 3's here. And then we go x equals negative 7 because 21 is 3 times 7. So if we're dividing it by negative 3, it needs to be negative 7. Okay? That's going to give us our number value, but we need to do it as an ordered pair, which means that, and if we remember this, x and y is an ordered pair. When we're looking for graph stuff, we have x then y. We know our x value is negative 7, and if you will go, oh, but we don't know the y value, We had it 0 at the beginning, so it's going to just come down here. And this would be our answer as an ordered pair. -7 at 0. Questions on this one, because I know this one. 24. We're going to do the same thing, but this time we're going to do it for the y-intercept. So if we're doing it for the y-intercept, we're going to make x equal 0. Doing that in this equation, we've got 7 times 0 minus 8y equals -42. At this point, we'll just cancel out the 7 and the 0 because 7 times 0 is nothing. So it sits there on the side. We have now, we're going to go back into reverse PEMDAS. There's nothing to add or subtract. So we switch up to multiply or divide, and we need to divide away from y. So we're going to divide a -8 on both sides of the equation. When we do that, it cancels out on this side, leaving us with y equals, and we're going to have a -42 divided by a -8. We know that 8 and 6 gives us 42. And because it's negative divided by a negative, that means that the 6 will be positive. So that means my y equals 6. But that's not my answer because I need to write it as an ordered pair. So we go back up here and say x was equal to 0. And we still write our ordered pair as x, y. So we'll go 0. And then y was 6. So we'll put a 6 there. And this is our answer as an ordered pair. That will be where the line crosses the y-axis. Realize there's a problem with this number. One of the students pointed out I did the wrong number there. So if we're just doing this, we'll just simplify these both by 2. So it'll be a 21 over 4. And since they're both negative, we just made them positive. So it'll be 21 over 4. And if we're doing that in a system, we'll just say 0. And then do 21 over 4. And that's how we write it fractionary, because we want to keep it fractions. Yeah, it's better as improper fractions, because then, then a mixed number, we don't want it. Mixed numbers, we showed them to you earlier just to let you understand that they exist. We don't want you doing math with mixed numbers, because it can get really complicated quickly between if you're multiplying 7 by 1/2 or if you have 7 1/2. What?
If you were to divide it.
Yes.
No, 5 points.
Wait. But we're doing it in fractions. Because if we do it in points, then we can't use this as rise over run procedure later on. For y equals mx plus b, always do fractions.
Because if you're doing the y and x, wouldn't that be for graphing? So
yes.
A decimal point would work.
A decimal point would work, but the problem that we're having with that is you want them to use those to find whole numbers to draw their lines between. For example, if you're trying to locate 2 separate points, you don't want them to use fractions. You want them to use whole numbers and draw between the whole numbers. We might show that later on in this questions, but I'm not sure. I think that's later on in your course, on the second half. Point slope is a really weird thing called m that also equals slope, which also equals rise over run. This guy, slope, he has an identity crisis. I don't know how to better explain it to you. He is everything, anything, all in between. And he also fits into this equation, y equals mx plus b. But we're not going to deal with that one in this question. We'll deal with that one in the later questions. Currently, as I said, m equals rise over run, which, if we want to say that in bigger terms, that means the change in y over the change in x. This will be for trigonometry stuff later, but we're just going to call it right now y2 minus y1 over x2 minus x1. Now, the crazy part about this is it doesn't matter which of these two solution sets I call to be 1 and call to be 2, as long as I keep those numbers together. The x2 is this one here. The x2 is that one there. As long as I keep it the same, as long as I keep the parts in the right spots, it doesn't matter if I name this set up here 2 and this set over here 1. All that matters is I keep the same guys in the parentheses in the same spots. So when I go, this is x let's just start this as x2, and this will be, oh, here, I'm just going to clear this whole section, make this a lot easier. Oh, come on. We're just going to delete this out. So we'll make this x2, and this be y2, and this will be x1, and this will be y1, just to show the fact that you can name these however you want, as long as you keep those numbers set together. That'll give us negative 19 minus a negative 1, which I'm going to say negative and negative make a positive. That's how I would denounce that there. On the second part, we have x2 minus x1. So x2 is negative 1 minus 11. And it's going to equal, let's do our numbers, negative 19 plus 1 is going to make negative 18. So we'll have a negative 18 here. I'm going to move this up and out of my way. Negative 1 minus 11. So that's going to be negative 1 bad guy, 11 bad guys, makes 12 bad guys. So that'll be a negative 12 there. So we have two negative numbers. We can make them positive, so it'll be 18 over 12. And then we can simplify this down by dividing both of them by 6, which would be 3 over 2. And that would be our slope or m value. Find the slope of a line. Slope of a line is where you want to look for 2 points that definitely go through their intercepts. Something like this here does not work. Do not use something like that. Use the ones here that are perfectly going through stuff. And we'll look at these and go, all right, so slope of the line is going to be at 0, 2, and this one is at 6, 0. And we could, no, bad. We could take this and we could run it through the whole rise over run situation, or because I know these are here and this is the graph, I can go 1, 2. So I went 2 down, right? So I have a negative 2. Remember how we said rise over run? So my rise was negative. My run is always going to be positive. All right? So I'm going to run 1, 2, 3, 4, 5, 6. So I ran 6 over, right? I ran 6 over, and I went negative 2 down. So I could simplify that to being negative 1 over 3. This is my slope, and I can prove this by saying I'm at a point, I go 1 down, and then I go 1, 2, 3 over, and I'm at another point that's on my line. That's a way to prove that. And the other cool thing about this, yep.
The rise is?
It's going to be 1/3, negative 1/3. Because when we rose, we actually fell instead. So let's say I started at this point here, again, right? But instead, I actually rose up numbers. If I went, 1, 2, right? I went 2 up. I now got to go, well, let's just go 1 up for now, not 2, because that's going to be a bad thing. We're just going to go 1 up to here. If we go 1 up, that's my positive 1 up there, right? I rose 1 number, right? But I got to go back 3 to meet it, right? So I'd have to go 1, 2, 3. But that would be a negative run. If I do that, it'll still be negative 1/3 either way. And we can do this by coming down here to a grid. Let's say that I had 2 over 5, negative 2 over 5. So that meant that I went down 2, and then I went 1, 2, 3, 4, 5. That would be my line, right? But if I also had a 2 over negative 5, I would just go 2 up, and then I would run backwards 5 spots. This is why, when you're looking at reciprocal values, a reciprocal would be 5 over 2 in this situation. We're starting at this point. I'd go 1, 2, 3, 4, 5, and go 2 over, And that line is 90 degrees to the other line. So there's your perpendicular lines and reciprocals. Remember when we did those? Uh-oh. Uh-oh. We're going to do some more. Question 27. Determine the slope of a line represented by the equation. As I told you before, the slope equals this weird thing called m, is slope equals rise over run. He's got all these names, right? But m. M fits into a specific equation equals y equals mx plus b. This equation will be used a lot in the second half of your course. But this here has that m. See how these guys are the same, right? So if I look at this over here and I went, this is y. That's him, right? This is x. We got a minus here, so technically it's a plus a negative b value. I'll explain that part later. But this whole portion here is an m, right? So that means that m equals negative 2 over 7, right? Just because he's the one touching the x, and that's how we said this equation, right? Because the guy touching the x is always going to be m. As long as it's set up in this equation where there's nothing here in front of a y, b's got its own value space, that means that this is m, right? And m is equal to slope, right? Determine the slope of the line. They just stuck it out there right in front of you. The red barn's color is red. It's right there. They put it in the name. They said, here's a slope. So you just got to remember this when it's like that. That's how it is. Now, if you had something like 2x plus 3y equals 12, just for happenstance, you don't have an m value here right now. You got to make it. So what you do is you'd subtract the 2x from both sides, giving us a 3y equals negative 2x plus 12. Divide all of these by 3. And at this point, you have y equals negative 2/3 x plus 4. At this point, this is your m value, and that's your slope there. Okay? Only when he looks in that form. So whenever they give you something that's not that form, turn it into that form. Use reverse PEMDAS to get to that form. Use it to isolate y, and that gives everything else its proper number. All right, showed you earlier, we're going to move over the things for 28 as well. So we got the negative 3x minus 7y equals negative 17. In this case, we want that y equals mx plus b form. We're going to love it, cherish it, hold on to it. It's our best buddy. So we're going to add 3x to both sides. We get negative 7y equals 3x minus 17. And then divide both sides by negative 7 to get y alone, right? So we get y equals 3 over negative 7, x minus 17 over negative 7. So that's going to be a plus. And we're just going to ignore that existed. Okay? This part here, currently, right now, is irrelevant. We don't need him. We don't have to do the math on him. All you got to do is look at this and say, is this in its simplest form? And it kind of needs to change because we're going to say that the top half gets the division because that's how professors like to look at it. And we know our slope will be negative 3/7. Okay? We did that by working it around to that point. We've got some out there. We've got some more empty ones out there. So for question 29, graph the linear line represented by the following on a table. That means I have to draw the table. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 15. Okay, I need to go one more. Try this. Ah! Come on, don't do this to me now. Yes, that's the midpoint, right? That looks about right. So, now I'm going to do the points. So, that's where we start plugging in these numbers in each individual point. We'll go, okay, so if this is 0, 0, we're going to go 1, 2, negative, and then we're going to go -4, so 1, 2, 3, 4. That's going to be one of our points. And then the next one's going to be at -1, -1. So go 1 over and then go 1 down. That's there. At 0, we go 1, 2 up. That's going to be a point. Go over 1. And go 1, 2, 3, 4, 5. That's a point. And then the next one is just about to be off our graph. So we have all the points sitting here. And what we'll do is we'll just take a line. If we put it through 2 points, we'll realize that it will continue to go through all of those points. My graph's a little bit weird, but that's how you'd make the line off of those points. And if you look at it, you're still doing the whole move 1 over and then move 3 up, vertical rise over runs. It's doing the same movements. Kind of started doing this one without the recording, so catch you guys up. Question 30. I'm looking at this, remembering I want y equals mx plus b form, and I'm going to start by finding a slope, and then I'll find the b. B is just equals the y intercept. So if we just went to x being 0 and looked, we would find exactly where the y value is. Since it's -4 here, we would just say that b is equal to -4. And we just already know that number. But for the other part, we need to find 2 points to get our slope. And this, is it 0, -4? Yeah, this is 0, -4. So to write that better, that point is at 0 equals -4. And this one over here is actually 10 at 0, -10 at 0. And we can rise over run these, or I could just say that I'm going to go 4 down. So I rose, -4 is my rows, because I went 1, 2, 3, 4. And then I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll have a positive 10 value on there because we went this way, and then we went this way. -4 over 10 simplifies to -2 over 5, and that will be our m value. And then we go over and we punch them in, and we say y equals -2 fifths x minus 4 would be the slope of this equation. Thank you all for paying attention. Have a good day. Good luck on your midterm.